Let's look at the answers to this first quiz. This first problem, first thing you ought to do is take out the x squared as a common factor. What remains is the 9x squared minus 121. That should be identified as a perfect square, a difference of perfect squares. So then that factors again 3x plus 11 and 3x minus 11. Done. This one over here, this needs to be identified as a difference. So now let's take a look at the problem number 2. Problem number 2 is a sum of cubes. Remember the sum of cubes. A cubed plus b cubed is going to factor into a plus b, and then a squared minus ab plus b squared. In this instance, a would have to be like the 5x. So a would be 5x plus y would be, or b would be the 4y. So then that's factored. And then you get 25x squared minus 20xy plus 16y squared. Done. I had people put 40 in here, and then that if that were 40, it would factor again to the 5x minus 4y, the quantity squared, but it's not. So, and this does not factor beyond that. Onward to problem number 3. Got a common factor. Okay, both groups have the x minus 2. Both groups have the x minus 1. This has an 8, that has a 4. So we can take out the 4 as common. And then we got the x minus 1. X minus 1, yeah. The x minus 2. Now, what's multiplied by this grouping to get back to that? You have to account for the x, and the x minus 2, and then plus 2. Now, a lot of people left it at this, and they lost the point because you didn't distribute here. So let's distribute there. Get x squared minus 2x plus 2. And that won't factor, so we leave it. 4x minus 1, x minus 2. Factored. Okay? Alright, this guy, quadratic trinomial, multiply the ends, negative 240. Play around with the factors of negative 240. So you get that negative 43. The combination that works there is 48 and 5. So we're going to rename that middle term. Bring it down, first term. The negative 43 is going to be now minus 48x plus 5x minus 20. Now we split it down the middle. The first two, common factor, 12n rather. Okay, common to n minus 4. Over here, plus 5, common to n minus 4. Common binomial factor, n minus 4. Common to 12n plus 5. Factor. Common factor here, 3x. Common to x squared minus x minus 2. This now factors to x minus 2, x plus 1. 3x out in front. Done. Okay, quadratic trinomial. You go trial and error if you want. Multiply the ends. Seems like a lot of you like that. That multiplies to 70. Combination of numbers, multiplying to 70, adding 37, 35, and 2. 14x squared is now rewritten as 35x plus 2x. Doesn't matter which one comes first, actually. Plus 5. Split it. Factor by grouping. First two. Common factor 7x. When removed, 2x plus 5. Plus common factor of 1. Remaining 2x plus 5. Common binomial factor 2x plus 5. Common to 7x plus 1. So 1 understood there. Done. Another problem here. Multiply the ends. 45 and 8. Find the combination of numbers. 45 times 8 is 360. Rather large number, but 360. Combination that works there. Combination that works there is 18 and 20. So the middle term is renamed as 18xy, 20xy, 8y squared down for the right. Group them. First two, greatest common factor, 9x. Common to 5x plus 2, plus 2y. Second two, pull down the sign, plus sign, common factor, 4y. It should have been y squared, okay? Common 2, 5x, 2y. Common binomial factor, 5x plus 2y. Common to 9x plus 4y. Now it's factored, okay? Number 8. Not quite. Some people made the mistake. This reads 1 minus x, that reads x minus 1. They are opposites. So we can work around that by pulling out a negative from the second grouping. If we pull out a negative, then we can reverse the order of that. Reversing the order of that, the x minus 1 is identified as a common binomial, common to a squared minus b squared. This difference of squares, factors again. Bring down the x minus 1, factor a plus b, a minus b. Always group these terms. Next, identify factoring, grouping, group the first three. First three is a quadratic perfect square trinomial. Factoring the x plus 2 quantity squared minus 9y squared. Now we have a difference of squares. Difference of squares, a squared minus b squared. Factors x plus 2 plus 3y. The other group, x plus 2 minus 3y. Done. Lastly, number 10, grouping, first two, common factor x squared. Pulled out, nope, common factor x cubed. You can see that power there. So x cubed is common factor. X cubed, common to x plus 2. Second one, minus 1 comes out, common to x plus 2. Now, x plus 2, common to x cubed minus 1. Now, I let a lot of people get away with leaving it at that, but really, this difference in cubes should be refactored again. X minus 1, x squared plus 1x plus 1, x plus 2 comes down. There it is. Everything factored completely.